Pair of straight lines, theorems. First theorem, angle between the pair of lines. That the equation ax square plus 2hxy plus by square equal to 0 represents a pair of straight lines. Then the angle theta between the lines is given by cos theta is equal to mod of a plus b by root of a minus b whole square plus 4h square. This we are going to prove. So here, these are the pair of lines passing through origin. That means this represents two straight lines which are passing through origin. Let ax square plus 2hxy plus by square is equal to 0 represents the lines first line L1x plus M1y is equal to 0. Equation number 1. Second line L2x plus M2y is equal to 0. Equation number 2. Here we are not taking any constants because both the lines are passing through origin. Only x and y terms. So equation 1 and equation 2. Then ax square plus 2hxy plus by square can be written as a product of 1 and 2. Because ax square plus 2hxy plus by square equal to 0 represents two straight lines. That means combined equation of these two is the given pair of lines. L1x plus M1y into L2x plus M2y. So simplify RHS, multiply L1x into L2x, L1 L2x square plus L1x into M2y, L1 M2xy plus M1y into L2x, M1 L2xy plus M1y into M2y, M1 M2y square is equal to L1 L2x square plus in the middle two terms xy is common. Let us take xy out. And still we are having L1 M2 plus L2 M1 will be remaining. Plus last term M1 M2 y square. Now compare like terms on both sides. Compare like terms on both the sides. See, in LHS and RHS we have an x square term, xy term and y square term. We are comparing both. So first x square term comparison. Coefficient x square coefficient A is equal to L1 L2. Next, xy coefficient 2h is equal to L1 M2 plus L2 M1. 2h is equal to L1 M2 plus L2 M1. Next, y square coefficient B is equal to M1 M2. This is the comparison. A L1 L2, 2h L1 M2 plus L2 M1, B M1 M2. Now actually we are going to find angle between the lines 1 and 2. Let theta be the angle between the lines 1 and 2. Then we have cos theta formula. Then cos theta is equal to. See, if the lines are a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 is equal to 0. From straight lines, angle between these two lines cos theta is equal to mod of a1 a2 plus b1 b2 by root of a1 square plus b1 square into root of a2 square plus a2 square is the formula to find angle between the two straight lines. But here what lines we are having? First and second, L1x plus M1y, L2x plus M2y. Our lines are L1x plus M1y is equal to 0, L2x plus M2y is equal to 0. So here you can compare these two and these two. So in this formula, cos theta formula, we are going to replace A1 by L1, B1 by M1, A2 by L2, B2 by M2. Then what we get here? A1, A2 means L1, L2 plus B1, B2 means M1, M2 by root of A1 square plus B1 square, L1 square plus M1 square into root of A2 square plus B2 square, L2 square plus M2 square. This is the formula. Hope it is clear here. This is the actual formula from the straight lines. Angle between these two lines, cos theta formula. Instead of A1, B1, we have L1, M1, A2, B2, we have L2, M2. No constants in our equations. Anyway, constants we are not using in cos theta formula. This we have to simplify. So what we need to prove here, cos theta equal to a plus b by root of a minus b whole square plus 4h square. Here already we got L1, L2 is a, M1, M2 is b. So numerator, you can replace L1, L2 by a, M1, M2 by, that we do later. Let us simplify the denominator part. L1, L2 plus M1, M2 modulus. I am combining the square root here, a root of L1 square plus M1 square into L2 square plus M2 square. Mod of L1 L2 plus M1 M2 by root of multiplying L1 square into L2 square plus L1 square into M2 square. So first, second bracket is multiplied by L1 square. L1 square L2 square plus L1 square M2 square. Next, multiplying by M1 square. M1 square L2 square plus M1 square M2 square. Multiplication. Mod of numerator as it is L1 L2 plus M1 M2 by root of, let us rearrange the denominator terms, L1 square L2 square. I am writing L1 L2 whole square. This one. Next I am taking last term plus M1 M2 whole square plus next L1 square M2 square, L1 M2 whole square plus M1 square L2 square or L2 M1 whole square. Now, next step, numerator as it is mod of L1 L2 plus M1 M2, denominator first two terms, it is like a square plus b square. A square plus b square can be written as a minus b whole square plus 2ab. A minus b whole square plus 2ab. Next, two terms also we have a square plus b square is equal to a plus b whole square minus 2ab. For the first two terms, a square plus b square, I am applying first formula a minus b whole square. That means L1 L2 minus M1 M2 whole square plus 2ab. 2 into L1 L2 M1 M2. Here A is L1 L2, B is M1 M2. Next two terms. Again a square plus b square. I am writing a plus b whole square here. A plus b. L1 M2 plus L2 M1 whole square minus 2ab. Minus 2. A is L1 M2, B is L2 M1. First one, a square plus b square equal to a minus b whole square plus 2ab. Second one, a square plus b square, a plus b whole square minus 2ab. Next term, mod of. Now I am going to replace L1 L2 by a plus M1 M2 by b in the numerator from our assumption. In the beginning, we have compared. So a is L1 L2. Here it is there. B is M1 M2. Next, coming to denominator part, root of L1 L2 first term. L1 L2 is a minus M1 M2 is b whole square. And here I am cancelling plus minus these two. Because both are same, this is also 2 into, just rearrange the terms L1 into M2 into L2 M1. Or in order L1 L2 M1 M2, both are same. So this is a negative term. Here it is a negative term, it is positive term, both are cancelled. The remaining plus here. L1 M2 plus L2 M1 from comparison, that is 2h. It is 2h whole square. Then mod of a plus b by root of a minus b whole square plus 2h whole square is 4h square. This is the proof for the first theorem. Angle between the pair of lines which are passing through origin. So take two lines without constants, L1x plus M1y equal to 0, L2x plus M2y is equal to 0. So product of these two equations we need to take and then compare with the given equation. Like terms on both the sides comparison. X square coefficient A is equal to L1 L2. Xy coefficient 2h is equal to L1 M2 plus L2 M1. Y square coefficient B is equal to M1 M2. This is the comparison. Later angle. So let data by the angle between the two lines 1 and 2. We have formula from straight lines cos theta equal to mod of a1 a2 plus b1 b2 by root of a1 square plus b1 square into root of a2 square plus b2 square. Instead of a1 b1 a2 b2 we have l1 m1 l2 m2 that we have written here. And then simplification. So this is the first theorem. Next, product of the perpendicular theorem. Show that the product of the perpendicular distances from a point alpha comma beta to the pair of straight lines ax square plus 2hxy plus by square equal to 0 is. So again, proof. Let ax square plus 2hxy plus by square is equal to 0 represents the lines same like cos theta theorem. Till the comparison, both are same. L1x plus M1y is equal to 0, equation number 1. L2x plus M2y is equal to 0, equation number 2. Then take the product and equate to ax square plus 2hxy plus by square. is equal to L1x plus M1y into L2x plus M2y. Multiply. Same like cos theta theorem here also. L1x into L2x, L1 L2x square, L1x into M2y, L1 M2xy, M1y into L2x, M1 L2xy, M1y into M2y, M1 M2 y square, L1 L2 x square. Middle two terms xy is common. The remaining terms L1 M2 plus L2 M1 plus last term as it is. Now compare like terms on both the sides. Compare like terms on both the sides. X square coefficient A is equal to L1 L2. XY coefficient 2H is equal to L1 M2 plus L2 M1. Y square coefficient B is equal to M1 M2. So this is a comparison. Next, what is theorem actually here? Product of the perpendicular distances from a point alpha comma beta to the pair of lines. See, these are the two pair of lines which are passing through origin. First and second. This is the origin here. Both are passing through origin. And there is a point P, say for example P alpha comma beta. Now perpendicular distance from P to the first line, let it be D1. Perpendicular distance from P to the second line, let it be D2. So they are asking us to find this product of these two distances, D1 into D2 is equal to question mark. This we have to prove. Product of the perpendicular distances, right? So first D1 is equal to perpendicular distance from alpha comma beta to first line. See, in straight lines, from the point x1, y1 to the line ax plus by plus c is equal to 0, perpendicular distance formula is there. Mod of ax1 plus by1 plus c by root of a square plus b square. From the point x1, y1 to the line ax plus by plus c equal to 0, perpendicular distance. Here, instead of x1, y1, we have the point alpha beta. Instead of ax plus by plus c equal to 0, we have the first line L1x plus M1y is equal to 0. Then this formula becomes mod of ax1. A is L1, x1 is alpha. So L1 alpha. Plus by1. B is M1, y1 is beta. So M1 beta. Plus C constant. There is no constant in our equation, 0. By root of a square means L1 square, b square means M1 square. So this we are going to get here. This mod of L1 alpha plus M1 beta by root of L1 square plus M1 square. Similarly, D2, which is perpendicular distance from alpha comma beta to the second line. Second line means L2x plus M2y is equal to 0. So here in this, instead of L1x plus M1y, I am going to take L2x plus M2y. Then it becomes mod of L2 alpha plus M2 beta, the root of L1 L2 square plus M2 square. Just 1 is replaced by 2. Mod of L2x, L2 alpha plus M2 beta by root of L2 square plus M2 square. These are the distances. Now finally what we require? Product of perpendiculars. So d1 into d2, multiplying both. First one, mod of L1 alpha plus M1 beta by root of L1 square plus M1 square into d2, mod of L2 alpha plus M2 beta by root of L2 square plus M2 square. Now combining the modulus in the numerator, mod of L1 alpha plus M1 beta into L2 alpha plus M2 beta. Similarly, in the denominator, combine the square roots. Together we will write root of L1 square plus M1 square into L2 square plus M2 square. Now we have to simplify both numerator and denominator. Denominator is like cos theta theorem as it is. Numerator is different. So mod of multiplying L1 alpha into L2 alpha, L1 L2 alpha square, L1 L2 alpha square plus L1 alpha into M2 beta, L1 alpha into M2 beta. So L1 M2 alpha beta plus next M1 beta into L2 alpha, M1 L2 alpha beta plus M1 beta into M2 beta, M1 M2 beta square. This is modulus in numerator. Similarly, denominator also multiply L1 square L2 square root of L1 square into L2 square plus L1 square M2 square, L1 square M2 square plus M1 square L2 square, M1 square L2 square plus M1 square into M2 square, M1 square into M2 square. Mod of numerator L1 L2 alpha square as it is. In the middle two terms, alpha beta is common. Take alpha beta common. Then remaining still we have L1 M2 plus L2 M1 plus last term as it is M1 M2 beta square. Denominator as it is like cos theta theorem. L1 square L2 square, L1 L2 whole square. Plus next I am taking last term M1 M2 whole square. Next L1 square M2 square, L1 M2 whole square plus M1 square L2 square, M1 L2 whole square. Numerator as it is L1 L2 alpha square plus L1 M2 plus L2 M1 so alpha beta plus M1 M2 beta square denominator under the root as it is like cos theta theorem. First two terms a square plus b square. A square plus b square. I am writing this as a minus b whole square plus 2ab. So a is L1 L2, b is M1 M2 here. A minus b. L1 L2 minus M1 M2 whole square plus 2ab. 2 into a is L1 L2, b is M1 M2. Plus next two terms. Again a square plus b square. Here I am writing this as a plus b whole square minus 2ab form. A plus b whole square minus 2ab. Where a is L1 M2, b is M1 L2. So a plus b. L1 M2 plus L2 M1 whole square minus 2 L1 M2 L2 M1. So here plus term minus term cancel because this is also like if you rearrange anyway it is the product 2 L1 L2 M1 M2 only minus plus is cancelled. In the remaining terms from the comparison L1 L2 can be replaced by a. L1 M2 plus L2 M1 can be replaced by 2H. M1 M2 can be replaced by B. So here L1 L2 is a alpha square plus L1 M2 plus L2 M1 is 2H alpha beta. M1 M2 is B beta square by root of L1 L2 minus M1 M2 whole square, a minus b whole square plus here it is 2H. See this once again. L1 L2 is a, L1 M2 plus L2 M1 is 2H, M1 M2 is B. Similarly in the denominator it is a minus b, here it is 2H. So finally what we get is equal to numerator as it is mod of a alpha square plus 2H alpha beta plus b beta square by root of a minus b whole square plus 2H whole square is 4H square. This is a proof of the second theorem. Product of the perpendiculars. So till the comparison, cos theta theorem and product of the perpendiculars both are same. After that, here we are going to apply perpendicular distance formula. For straight lines, perpendicular distance from x1 y1 to the line ax plus by plus c equal to 0 is mod of ax1 plus by1 plus c by root of a square plus b square. D1 is perpendicular distance from alpha beta to the first line. See here our first line is L11x plus M1y is equal to 0. So I am comparing this L1x plus M1y is equal to 0 with ax plus by plus c equal to 0. Then this formula becomes here ax1. A is L1, x1 is alpha. So it is mod of L1 alpha plus by1. B is M1, y1 is beta. C is constant, no constant in our equation, which is 0. By root of a square plus b square. Here a square is L1 square, b square is M1 square. This is the first distance. Similarly, second distance, just 1 is replaced by 2. Here we will compare this L2x plus M2y equal to 0 with ax plus by plus c equal to 0. Then distance formula becomes mod of L2 alpha plus M2 beta plus 0 by root of L2 square plus M2 square. Why this 0? Because there is no constant in our equations. Then finally multiplying both. Right? Hope it is clear. It is the second theorem. Very, very important theorems for 7 months.